Okay, video number 4 for our Chapter 10 specials here. We are going to, this is working with nonlinear systems. Okay, so by nonlinear, what I mean is stuff like this. You'll notice there's x squareds and y squareds in it. Either one, any square or any kind of exponent or radical, anything like that makes it nonlinear. All right. So the basic method is to use either substitution or elimination to solve the system. Okay. It can be helpful to graph the system on a calculator to get an idea about how many solutions there are. However, it's not strictly necessary. Okay. So I'm going to solve a couple of methods, a couple of them here. I'm not going to do the graphing. The book does talk about it, and you can look that up if you want to do it on the calculator. The issue with the calculator is that you have to solve the equation for y, and I can see this one has a y squared, so you'd actually have to solve the square root of 2 different equations. It's kind of a mess. Okay, that's why I'm not going to bother with it. In general, though, you you do need to be careful with these because there can be anywhere from no solutions. There can be 1, 2, 3, or 4 solutions to these. Okay, so you have to be careful. All right, so let's have a look and see how this works. So for this one, we're going to use substitution, and the reason I'm going to use substitution is kind of like the reason I used substitution in the 2x2 systems that were linear. See, I have a y squared all by itself there. That is nicely set up. It's very easy for me to get an equation that simply says y squared equals something, right? So what I'm going to do, I'm going to look at this second equation. 5x squared plus y squared equals 36. I'm going to subtract 5x squared from both sides. All right, so now I know that y squared equals 36 minus 5x squared, right? So then let's look at this other equation. I've got x squared minus 5y squared plus 76 equals 0. Well, where I have a y here, I'm going to plug in this whole quantity. Okay, x squared minus 5 times 36 minus 5x squared plus 76 equals 0. All right. So, all right, let's multiply this out. X squared, well, minus 5 times 36 is minus 180. And then minus 5 times minus 5x squared is 25x squared. What happened there? Squared plus 76 equals 0. All right, well, we're going to collect like terms here, right? X squared plus 25x squared is 26x squared. Minus 180 plus 76 is going to be minus 104 equals 0. Okay, as it turns out, if we divide through by 26, we're going to get x squared minus 4 equals 0. Hopefully you recognize that. X minus 2, x plus 2 equals 0. So we got 2 answers for x, 2 and minus 2, right? So then what we need to do is stick both of these up into our equation for y squared up here. All right, so y squared equals 36 minus 5 times 2 squared. So y squared equals 36 minus 20. Y squared equals 16. So that gives us y. If you take the square root of both sides, remember whenever you take the square root, right, take the square root of both sides, you have to take plus and minus, right? So that's going to get us plus and minus 4. So we stuck 2 into this. We're going to get 2 comma 4 out of it. and then but we also get 2 comma minus 4. Okay. Now then we stick in the minus 2 for x as well. All right. Y squared equals 36 minus 5 times minus 2 squared. Y squared. Now this turns out to be the same. 36 minus 20. So y squared equals 16. Y is going to be the same, plus or minus 4. This time we stuck in minus 2, right? So we get 2 points from here, minus 2 comma 4 and minus 2 comma minus 4. So you see this is one of those, we have 4 separate points. 1, 2, 3, 4. If what I have seen, my experience is, if people are going to make a mistake on these things, it's usually here when they take the square root at these last 2 steps, kind of, they forget that they need to do 2 of them. So the positive 2 for x, because of the square root at the end for the y, gets you 2. And the negative 2 for x, because of the square root at the end, also gets you 2. All right? Really what's kind of happening here, because the x's are squared and the y's are squared, that gets us, that kind of doubles us twice. We get 4 answers. That's not uncommon. Okay? It doesn't always work that way, but it does happen. All right, so now let's look at the other system. We'll use elimination for this one. Now, the thing I notice about this one, you could have used, see the single x squared here, this here? So we really could use substitution for this one too, using the x squared. But this one also is going to work well with elimination. Now notice this. You could do it with either the x squared or the xy. It's really better to do the xy because you want to get rid of a variable, right? Actually, so I'm going to take that. The x squared wouldn't work because we'd still have both an x and a y in these other terms. But so I'm going to get rid of the xy's. I'm going to take this second equation here, and I'm going to multiply the whole thing through, right? This whole second equation, both sides of it, by 5. Okay, 5 times 2x squared is 10x squared minus 5xy equals 15. And then the first equation is x squared plus 5xy equals 18, right? So if I add these two together, I get 11x squared. The xy's cancel, right? Minus 5xy plus 5xy. And then 15 and 18 is 33. All right, we'll divide both sides by 11. I now have x squared equals 3. Solve for x. We're going to take the square root of both sides. And again, remember you can do the plus and minus. So we now have x equals plus and minus the square root of 3. Okay. We could go either way with this. Again, we can plug this into either one of these two equations. Okay. Now I'm going to notice something here. So we got 2 answers for the x. Last time, each answer for x got us 2 different y's, right? But if you look at the y's here, this time they're not squared, are they? There's no squaring going on for the y's. So this is going to get us 1 answer for each y. So in other words, we're going to have 2 answers for this one, 2 that come from the x and 1 from the y. All right, so I'm going to stick in square root of 3 first. Let's go ahead and use, I don't know that it makes it. Let's use this 2x squared here. So I'm going to use 2x squared minus xy equals 3. Looks to me like these two equations are equally hard to plug stuff into. All right, so now x is going to be square root of 3. So 2 times square root of 3 squared minus square root of 3 times y equals 3, right? Square root of 3 squared is 3, so that's 6. 2 times 3, 6. Minus, I'll put the y in front. I'm going to do it. So square root of 3y, remember the y is not under the square root, equals 3. Subtract 6 from both sides. Minus square root of 3y equals minus 3. All right, so I'm going to come up here with this. Let's recopy it. Minus square root of 3y equals minus 3. So I'm going to divide both sides by minus square root of 3. Now this is maybe a little tricky here. On the left side, the square root of 3, minus square root of 3's cancel, right? So I've got y equals minus 3 over minus square root of 3. Well, I've got two minuses, those will cancel. What is 3 divided by the square root of 3? Well, if you think about it a minute, let me try this. If I had x squared divided by x, what would I get? Well, they would divide, the x would divide against one of the squares, I'd end up with an x, right? Well, you see that 3 is square root of 3 squared, right? Square root of 3 squared is 3, right? So in the same way, what I'm going to get out of this is square root of 3. I realize that's a little tricky. So our first point, x was positive square root of 3, and y is positive square root of 3. There's our first point right there. That's our first solution to this one. So let's stick in negative square root of 3 into the same equation. 2 negative square root of 3 squared minus negative square root of 3 y equals 3. All right, well, when you look at this first one here, when you take a negative and square it, it becomes a positive, right? Negative times negative is positive. So this minus square root of 3 squared is 3 again. 2 times 3 is 6. And then minus minus is a plus. This time it's plus square root of 3y equals 3. Subtract 6 from both sides. I'm going to get square root of 3y equals minus 3. All right. You see where this is going? So this time when I divide both sides by square root of 3, I'm going to get y equals minus 3 over the square root of 3. And this is going to turn out to be y equals minus square root of 3. So our two solutions for this one, the x was minus square root of 3, and that also got me a minus square root of 3 for the y. All right. So these are our two solutions here. Minus square root of 3, comma minus square root of 3, and square root of 3, comma square root of 3. All right, those are the two methods. We used elimination for that second one. We used substitution for the first one. You do have to be careful with these. One thing about these is that from one system to the next, they can look a lot different. If you get stuck on one, please feel free to use the Ask My Instructor to send me a question. I will be glad to help you with it. And also remember, now if you send the Ask My Instructor, please include a phone number. And anything you can tell me about where you're getting stuck. Most likely I won't use the phone number. I'll probably just send you a worked out answer. But depending on the question and what you've written me, I might well call you to get some more thoughts about just what you need help with. All right, that's it for this one.